Pharma Chemistry Academy. So this is second year, second semester Pharmaceutical Organic Chemistry 5th unit named Oxidation Reduction Reaction topic. So that is Oppenauer Oxidation Reaction. So Oppenauer Oxidation Reaction. So before going to discuss about Oppenauer Oxidation Reaction, so we discuss some basic terms for this reaction. So first one is oxidation. So oxidation is addition of oxygen or removal of hydrogen from a compound is known as oxidation. Next, reduction. So addition of hydrogen to a compound or removal of oxygen from a compound is reduction. So next, secondary carbon and tertiary carbon. So secondary carbon means a carbon which is attached to adjacently to two carbons or two immediate carbons. So that carbon is known as secondary carbon. So here carbon is attached to two different carbons. So that's why this carbon is secondary carbon. So next, tertiary carbon. So tertiary carbon means a carbon it is attached to adjacently three carbons or immediate carbons. So that carbon is tertiary carbon. So this carbon is attached to 1 2 3 immediate carbon. So that's why this carbon is tertiary carbon. So those carbons may be alkyl groups like methyl, ethyl, propyl groups or any other carbon containing groups. So here the next one is secondary alcohol. Secondary alcohol is a carbon which is holded by a hydroxyl alcohol group. So to that carbon, if two carbons or two alkyl groups are attached, so that compound is a secondary alcohol. This carbon is secondary carbon which is attached to hydroxyl group. So this whole compound is tertiary alcohol. So next, secondary alcohol. Next, tertiary alcohol, a carbon which is holded or bears the hydroxyl group and it is attached to three carbons. So this carbon is tertiary carbon having the hydroxyl group. So that's why this compound is tertiary alcohol. So next we move on to acetone. So acetone, so in the acetone word, so the suffix is "-one". So whenever "-one" suffix is observed in organic compounds, that compound is belongs to the ketone functional group. So ketone functional group is how we can written to the carbonyl group. C double bond Y is a carbonyl group. Under this one, aldehydes and ketones both comes. So to the carbonyl group, two alkyl groups or two substituents are present. So that is ketone. So acetone is the ketone. So next, to the carbonyl group, so one side alkyl group or any substituent and another side is hydrogen is present. So that is aldehyde. Acetaldehyde is an example. So next, isopropane. So isopropane, CH to the CH group, two methyl groups are attached, that is isopropane. So in this place any group can be attached, any atom or group can be attached. Next, isopropoxide. So to isopropane, in place of two adjacent CH, any oxygen is attached, so that is isopropoxide. So if two propoxide groups are attached, so that is diisopropoxide. If three, that is triisopropoxide. So this is isopropoxide, CH3 CH2 oxygen is attached. So to the isopropane oxygen is attached, so this is propoxide. So if two molecules are attached, so that is diisopropoxide. To isopropoxide, three molecules are present, so that is triisopropoxide. So next we are moving Lewis acid. So Lewis acid an electron pair acceptor from Lewis base. So why it is accept the electron from Lewis base means it have the electron deficiency, then only in order to fulfill that it accept the electron pair from Lewis base. Example for this one is aluminum trichloride and lithium aluminum hydride. So these are always want electrons from nucleophile or Lewis base, so in order to get the octet configuration. So in this Al, which is a Lewis acid metal, so in this one aluminum, so which is a Lewis acid metal. So these having the electron deficiency. Next, Lewis base. So Lewis base is the electron pair donor. So because it has electron cloud richness in its structure, so that's why it is an electron pair donor. So it donates electron pair to Lewis acid which have the electron deficiency. Example, the compounds consist of hydroxyl group, amine group. So on the oxygen, two lone pair of electrons are present which are unshared, so having the electron richness, so this is a Lewis base. So on the amine, on nitrogen, so unshared electron pair is present, so that's why it is also a Lewis base. So those Lewis bases may have the negative charge, so having the one more electron pair or having the in neutral state, that means with the lone pair of electrons. So next, coordinate covalent bond. So before going to that, we discuss about covalent bond. So covalent bond means sharing of electrons equally between an atoms or molecule, so that bond is known as covalent bond. So suppose hydrogen, it is formed by equal sharing of electrons between two hydrogen atoms. So next one is ethane. So in ethane, two methane molecules will present. So in that, two carbons share the electrons equally between first carbon and second carbon and forms the ethane. So this is for molecule, this is for atoms. Okay, this is for also it is also a molecule, a small molecule, it is a large molecule. So in coordinate covalent bonds, so one atom of molecule having the electron pair for donate, and in another molecule the atom have the empty orbital for accepting the electrons from the donor. So in ammonia, on nitrogen, one pair of electrons are ready for donate. So whereas in boron trifluoride, on boron, one empty orbital for accepting the electrons. So here ammonia gives pair of electrons, boron trifluoride accepts the electron from ammonia. So donor to acceptor bond is represented by the arrow mark. So this is the between two molecules, this is a coordinate covalent bond. So next one is electron negativity. So electron negativity is electron withdrawing capacity of atom in a molecule than other atoms in a molecule. So for good example for electronegativity, that means it can withdraw the electrons from atoms in molecules. So example, in so many of the molecules, elements like oxygen and sulfur have the more electronegativity when compared with the nitrogen and carbon. So similarly, nitrogen have the more electron negativity, that means electron withdrawing capacity, than carbon in some organic molecules. Next, oxygen valency. So in this topic, the oxygen valency is 2. So when it has the 2 valency, that means it when it forms the bond with the two atoms or two atoms or two molecules, then it is in stable state. So when with the two unshared electron pairs, so when it is forms the bond with the another one, so then that in that situation the oxygen is not stable, so that bond will be broken by the oxygen, so in order to get the stability. Similarly, when oxygen is bonded with the one atom or group, so then it in that case it all wants to form the bond with the another group. So how we get it, it can form the bond, so by donating itself pair of electrons. So in that way it loses one pair of electron, then it gets a positive charge, that means electron deficiency. So by donating electrons, oxygen can forms the bond with the another atom or group, so then it gets the 2 valency, it can forms the bond with the two groups. Next one is reversible reaction. So reversible reaction is so irreversible reaction is from the reactant product will be formed. So whereas irreversible reaction from the product from the reactant product will be formed, and from the product reactants will be formed. So that is an reversible reaction. So reaction can be happens in both sides. So this open-hour oxidation is reaction is the opposite of Merwin-Pondroff's reaction. So opposite of Merwin-Pondroff's reaction. So Merwin-Pondroff's reaction. So we will discuss about the open-hour oxidation reaction. So with reaction and mechanism.